Good morning, dear students. Myself Devraye-Patil, Head Department of Chemistry, late Rameshwar Creations College on Pit. Today, we will discuss our new topic, that is Schrondinger wave equation. This equation gives the wave nature of electron in an atom. So, Schrondinger described this equation, and from this equation he calculated the probability of electron in an atom. So basically this equation based on wave mechanics, as the electron as a standing wave around the nucleus. So we know the standing wave equation is psi is equal to a sine 2 pi x by lambda. So where psi is the amplitude, x is the displacement that is wave must be traveling, and lambda is the wavelength, is constant. So we differentiating this equation 1 twice, we get, that is, by differentiating this equation we get d psi upon, that is, dou psi upon dou x is equal to a 2 pi by lambda cos 2 pi x by lambda. Again we differentiating this equation, we get dou square psi by dou x square is equal to minus a 4 pi square by lambda square sin 2 pi x by lambda. So from equation 1 we get dou square psi by dou x square is equal to minus 4 pi square by lambda square into psi. So this is the differentiating equation of standing wave equation. So already we know the de Broglie equation is lambda is equal to h by mv. Then by taking square of both sides we get lambda square is equal to h square by m square v square. Putting the value of lambda square in above equation, we get dou square psi by dou x square is equal to minus 4 pi square by lambda square into psi. So is equal to minus 4 pi square by h by, here putting the value of lambda square, that is h square by m square v square into psi. By rearranging this equation we get minus 4 pi square m square v square by h square into psi. This is equation number 3. Again we know the total energy is the sum of kinetic energy and potential energy, that is E is equal to Ke plus Pe, that is potential energy, where E is equal to half mv square plus potential energy. By rearranging this equation we get half mv square, that is kinetic energy, is equal to the total energy E minus potential energy. So rearranging this equation we get mv square is equal to 2 E minus potential energy multiplying by m to both sides, we get m square v square is equal to 2m E minus potential energy. Putting the value of m square v square in equation 3, that is in above equation, the equation 3 is dou square psi upon dou x square is equal to minus 4 pi square 2m total e minus pe by h square into psi. So dou square psi upon dou x square is equal to 8 pi square m by h square into e minus pe into psi. So rearranging this equation, we get dou square psi upon dou x square plus 8 pi square m by h square e minus pe into psi is equal to 0. This is the one-dimensional Schrondinger wave equation. We know that the electron moving around the nucleus, so the probability of electron in an atom is not fixed according to the Heisenberg uncertainty principle. So the probability of electron, the electron may have on x-axis or y-axis or z-axis anywhere in the atom. So the three-dimensional equation for Schrondinger wave equation is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square e minus potential energy into psi is equal to 0. This is the three-dimensional equation for Schrondinger wave equation, where delta square psi plus 8 pi square m by h square into e minus pe into psi is equal to 0, where delta square is the Laplacian operator. This is the Laplacian operator, and this is the three-dimensional equation for Schrondinger wave equation. So students, write this equation, and this is the very simplest form of this derivation, so which is helpful to understand and remembering this equation. So thanks for watching this video.